Hi everybody, it's Mrs. Cassill. I wanted to show you your Crumple Zone Engineering Design Challenge. This module is now the top module in our class. If you open it up, you are able to start this as soon as you want, and it will be completed by next Friday. During class next week, this is all that we're going to work on. Our time together will be spent collaborating and getting help and working on this lab. There are several different components to this lab, and they're all broken out here specifically. There's a brainstorming session where you're going to discuss why do new cars get damaged so easily. This idea will come up again a little bit later in your official lab. There's some articles that are very brief about momentum and impulse. You have instructions to open and annotate these. This is for a grade. There are two different explorations. One that is about vocabulary and making sure that each of the terms that we use so specifically when we're talking about momentum and impulse and collisions, that you understand those. And there's a lab here where you're exploring crumple zones. The last two parts, there's a quiz, but the big one right here, this is the actual engineering design challenge, and I wanted to give you a brief preview of this one. So, hide my little menu here so it's centered on the screen. This is due by Friday, December 18th. It is worth 30 points. It is in the assessment category. This is your test for this unit. Your challenge is to design a crumple zone for a vehicle to protect a passenger from an impact. You will work with a team to brainstorm, then you will build and test your own prototype. There are two documents that are part of this. So one, there's a big old slideshow that is something your team will make copies of. You will share it together as a team and share it with me so that I can check it and see what you have completed. That will be part of your final grade. Then there's an independent lab document that is right here. Okay, the independent lab document looks like, oh, I forgot, I'm in student view. It never lets me show things when I'm in student view. Let me try it one more time. Actually, sometimes it does let me. So there's a little bit of humanity in our listeners. Sometimes it works. Yeah, no, see, authentication failed because I'm being Baba Shaniqua right now. I'm not being myself. So there's the lab document that walks you through your procedure. It has places where you're going to collect data, but most of the information you need you'll be able to find in this slideshow. The team will make a copy of this, collaborate together in it, and turn it in. This walks through the entirety of your challenge, clarifies what work is teamwork versus independent work. There are several different brainstorming sessions with some video prompts to get you thinking about it. This is the sum total of your challenge here. Your job, and I know it's a little bit big on the screen. Let me go ahead and pop it down. So there we go. You are going to design safety features for a vehicle that are meant to protect a passenger from an impact. You're going to build a prototype from the listed materials and stay within a budget. A raw egg will represent your passenger, and then in order to test your prototype, we're going to drop something on it from a specific height. You can imagine just putting an egg on the ground and doing that. You will break the egg. So you have some work to do to construct something that will protect it, just like a car protects your squishy little self when you get in a collision. A successful design protects the passenger from the impact, yielding an unbroken egg. So those are the basics of what your challenge is. Some of you, your creative juices are flowing. Some of you are like, thank goodness I get to meet with a team for a few minutes so that I can collaborate to get some ideas. This is very possible. Very, very possible, in case you were thinking it was impossible. So, a couple things. There's some checklists for what you'll do. You'll notice there's a big heading that says team. Those are the things we'll work on during our Google Meets next week. There's some hints about the materials, another video check-in for you, a rubric, a suggested timeline, and here's the sample budget. Reminder, you can pick up a kit of these materials ready for you at school. So if you go to the Northeastern Library, there is a smorgasbord of this already collected for you. I think a ruler, a paper ruler, and and string are the things that you may need to obtain or you need to cut there. They're there at the school. You're also able to source these materials yourself. If you're like, dude, I got all this stuff at home, feel free to use it. If you're like, I'm not going to use anything except for sheets of paper, well, good for you, okay? Then if you've got that at home, you can do that. It's entirely up to you how you use your design, right? Remember, we're part of a community still. I've had a number of questions about what can I do if I can't get to school during the hours that the library is open. Well, reach out. Do you have a teammate or a classmate who is also attending our class or who is able to go visit the school? I have no doubt that they will be understanding and supportive if someone goes to pick up materials on your behalf and who could drop them off with no contact on your doorstep. So I know that that's a risk to take, but this is also a time where we're trying to figure out new ways to support each other than we could before. If something's absolutely impossible, please reach out to me. I'm always here for you. I'm your ally, right? So this challenge will be fun. I'm really looking forward to doing this with all of you, even though it'll be remote and it won't be the same. I'm really looking forward to it. I think we'll have a lot of fun together. All right, so there you go. That's your general overview of your Crumple Zone Engineering Design Challenge. Good luck, everybody.